Well, in an effort to do a little bit more with problem solving, I'd like to talk to you about these expressions that we often use, consecutive integers, or consecutive even integers, or consecutive odd integers. So first of all, integers are positive and negative whole numbers, like a -3 and a -2 and a -1 and 0, 1, 2, 3, and they go on in either directions. So those are integers. So 3 consecutive integers. Let's just pick of several and just write examples down. So example number 1, 3 consecutive integers. Number 1, 2, and 3. Those are 3 consecutive integers. Another example, 12, 13, 14. Another example, a -4, a -3, a -2. They're in order, smallest one first, and consecutive. But let's go back to the 1, 2, and 3. So let's not keep these around for now. Let's say I wanted to write these in terms of a letter x. So let's let x represent the first integer. In our example that I've got written here, then x would be representing the number 1. So if this is represented by the letter x, then what would you have to do to this letter to get just one more beyond that number? To just grow it by 1, you'd have to take the previous number x and add 1 to it to get to the number 2. And then to get to the number 3, you'd have to start with the first number, that's the number 1, and add 2 to it to get to the number 3. So a way to express as variables 3 consecutive integers is x is the first, x plus 1 is the second integer, and x plus 2 is the third, because if x was a 12, then the next integer would be found by putting a 12 in for x and adding 1 to it. And 12 plus 1 would give you 13. And then to get the third one, you'd put x is 12 and add 2 to that, and you'd get these 3 consecutive integers, 12, 13, and 14, by letting them be represented by x, 1 more than x, and 2 more than x. Okay, let's list an example of 3 consecutive even integers. So let's just give them an illustration. So let's use the numbers 6, 8, and 10. But let's let the number 6 be the first integer, and we'll represent that by the letter x. Well, how much more is this one than that one? Isn't that 2 more than that one? So the way we would write an expression for the second of these consecutive integers is to take the first, the 6, and add 2 to it in order to get the 8. But then, to get the third consecutive integer, we'd take the original 6 and we'd add 4 to it in order to get to the 10. So if we started with x, which is 6, 6 plus 4 is 10. So the first integer, when we're looking at consecutive even integers, is x. X plus 2 would be an expression for the second consecutive even, and then x plus 4 would be the third consecutive even. Just an expression is what these are, expressions for these integers. Okay, let's go with some odd integers. So let's talk about number 3, 5, and 7. Those are consecutive odd integers. So let's say the first one was really represented by the letter x instead of the number 3. How much bigger is the 5 than the 3? Isn't it just 2 bigger than the 3? So while we're talking about consecutive odd integers, we have the exact same expressions as we do for consecutive even integers, because odd integers are 2 away from one another for the first 2, and 4 away from one another for the first and the third. So x would be the first odd integer, and x plus 2 would be the second odd integer, and x plus 4 would be the third. Even though we're talking about odd numbers, we add 2 to go from one to the next, and we add 4 to go to the next one. All right, so what we have now here is a story problem involving this. So we have two adjacent classrooms, and the room numbers on the doors are two consecutive even numbers. So here's the two doors, and one of them is the door called X. Well then, if they're consecutive even integers, if the first one is X, then the next one would be 2 more than that, X plus 2. So this door would have on it X plus 2. And it says that the sum of those two doors, if you will, classroom doors, is 658. So we take X plus the X plus 2, and we'd set it equal to the 658. And then on the left, we'd combine our like terms. 1x and 1x is 2x. Now we'll subtract 2 from both sides of the equation. And then we'll divide by 2. And when you take 656 and divide it by 2, you'll find out that x is equal to 328. So the first classroom's door number is actually the number, I'm going to redraw this. The first door is 328, and the second door, it's a consecutive even integer, is 330. This is the doorknobs I'm putting on here. So room 328 and room 330, do they add up to be 658? Yes, they do. Okay, let's do this again. The code to unlock a student's combination lock happens to be 3 consecutive odd integers. So here's the first, here's the next one, and here's the next one, because remember, the first might be the number 5, then the next one would be 2 more than that, like a 7, and the next one would be 4 more. But remember, it says that the sum of those is 51. So I have to put a plus sign between these expressions, because the first number plus the second number plus the third number adds to be 51. And then 1x and 1x and 1x adds to be 3x. And 2 plus 4 adds to be 6. So I wanted to get those cleaned up terms on the left-hand side. And now I'll subtract 6 from both sides, and I'll have 3x equals 45. And when I divide by 3, I'll find out that the first number on the lockers is the number 15. Well, the next one is an odd number. They're consecutive odd integers, so the next would be 17, and the next would be 19. And your check would be to add those up and see if they equal 51. Pretty sure they do. Okay, one more. So the length of a rectangular parking lot is 10 yards less than twice its width. A rectangular parking lot. All right, so it compares, this problem compares the length, this long side. It's 10 yards less than twice its width. It compares it to the short side. So let's let the short side right here be the width of this rectangular parking lot. So remember, the length, the long side, is 10 yards less than, that means I'm going to have to subtract 10 from something, twice its width. So if the width is at x, twice its width is 2x, and then I want that to be 10 yards less than twice its width. So now I'm going to go ahead and put a 2x minus 10 up here as well, because these two sides are the same, and I'm going to put an x over here. And it says that the perimeter is 400 yards. The perimeter means this plus this plus this plus this. So you could go ahead and just add all these expressions up. So see this x, and then this 2x minus 10, and then this x, and then this last 2x minus 10, that perimeter has to add to be 400. There is a formula that says twice the length plus twice the width equals the perimeter. So you could have taken 2 of these x's and gone, or let's go 2 of the 2x minus 10s because those are the lengths, and then 2 of the widths. And you would have gotten, here you'd had a 4x minus 20 plus this 2x. Well, down here, 1x and 2x and 1x and 2x is going to total to be a 6x. That's what I would have gotten right there. And then this minus 10 and this minus 10 totals to be a minus 20. And then finally now, I'm going to add 20 to both sides. Remember, I'm trying to solve for x. So I'll have 6x equals 420. When I divide by 6, I'll find that the width is 420 divided by 6 is 70 feet. Let's go back to my picture now. So x is equal to 70 feet. Then right here I'd go ahead and take 2 times the 70 and then subtract the 10. 2 times the 70 is 140. Subtract the 10 is 130. So I find out then that the width is 70 feet and the length is 130 feet. And if I take 2 of both of those, 2 of these and 2 of those, they should add up to be 400 feet, and they will. Very good. That was one of the more challenging problems because it involves we've been doing some problems that involve consecutive integers, even and odd, and then here's something that involves the perimeter of a shape as well as describing the length and width in terms of x.